All right, polarity. So polarity builds off of what we just did in the last lesson on Lewis structures. And polarity, like the name implies here, is when sharing gets uneven. So sharing is not always going to be perfectly even. Think about like when you're sharing something with your siblings. Now, I remember my mom, like I have two brothers. And if there was ever a situation where we had to share something, like food especially, like a candy bar or a pie or a cake, the rule was whoever cut it got the last piece. And that ensured that it would be shared as evenly as possible. Otherwise, like if I got to cut it and I got to pick first, it's like, no, I'm going to take 90% and leave 10% for my brothers. And that's what polarity is where, you get one has it more than the other. It's not a 50-50 relationship. And because of that, there's going to be a slight charges on it. And those slight charges are going to be called poles. All right. And so we'll kind of look at what that looks like here. All right. So polarity is caused by one of the atoms attracting the electrons in the bond more than the other. If you remember back from our periodic trends, that's electronegativity. And so we're going to look at that more here in a moment. So like I said, it's like splitting a candy bar. And so in this case, I've got two atoms. But this atom right here, notice it's got more of this bond on its side than this one over here. So the electrons are more on this side, which means there's going to be a slight negative charge on this end of this bond and on this end of the molecule because the electrons are spending more time on this side. They spend less time on this side, which means it's going to have a slight positive charge. And so I got a positive pole on this end and a negative pole on this end. Okay, so that's what's going on with polarity. All right, so once again, it's based on electronegativity, which we've already seen. The higher the number, the more it'll attract the electron and then have a slight negative charge on that end. Okay, here's kind of looking at the nonmetals with the exception of hydrogen. Well, hydrogen's right there on the edge and boron spot. Because boron doesn't do much here in terms of covalent bonding. All right, so you will always be given these electronegativity values. You do not need to memorize them. We just simply need to look at them and use them to figure out what's going on. So we're going to look at the electronegativity of the two atoms sharing the bond. If it's equal, then the bond is said to be nonpolar. If they are not equal, then the bond is polar and is signified by an arrow that looks like this, going from the positive pole to the negative pole. So the lower electronegativity gets this part of the arrow, the higher one goes here. So it's always going from low to high. And so this looks like a plus sign, and it goes on the positive end, which should make common sense there. All right, let's look at some examples. All right, carbon and hydrogen. Carbon has an electronegativity value of 2.5. Hydrogen has a value of 2.1. So the polarity is, this is the low one, this is the high. So the arrow is going to go to the left from low to high, and it looks like that. Usually it's drawn underneath the bond. A lot of times it has to be shorter than the bond just because you don't have a whole lot of space. You'll see that on the key. Okay, nitrogen and oxygen. Once again, low to high. So here's my low one, here's my high one. It goes this way. And then finally, nitrogen and chlorine. They're both 3. So we would say nonpolar. Usually people just write NP. NP is understood to be nonpolar. All right, so that's the polarity on a bond. Unfortunately, bonds do not exist in a vacuum. They exist in a molecule. And so each bond can have its own polarity, but then the molecule has polarity of its own. And we haven't gotten to Vesper shape, but that comes into play. And I'll play that out a little bit more when we look at that tomorrow. But you can use a Lewis dot structure to figure this out. All right, so let's look at some examples. So if we do the Lewis dot structure for CH4, carbon tetrahydride, or methane as it's commonly known, remember the polarity of carbon and hydrogen goes from the hydrogen to the carbon. So it goes in like this. But look at this. What are these two arrows going to do? If you have any experience with physics and force diagrams, this will be a little more common sense to you. But think about it. If I got somebody pushing this way and I got somebody pushing this way, they're going to cancel each other out. Same thing here. This one's pushing this way, this one's pushing this way. They cancel each other out, giving me an overall non-polar. Okay? So even though the bonds are polar, the molecule is non-polar. Okay? So that's important. All right. Water. This is where what we're going to learn in the next lesson called Vesper comes into play. Because Vesper teaches us that water structure is not going to be in a straight line. It's not going to be a hydrogen, oxygen, hydrogen. That it actually forms what we call a bent structure. And we'll learn that in the next lesson. But I'm still going to use it as my example here. Okay. So we've got, so just double check with the key for now, or you can go ahead and do the Vesper lesson, and that will help you get this straightened out. But if we look at this arrow is going this way, and this arrow is going this way. All right, so if it helps, you can kind of think of it like if we had an x-axis going this way and a y-axis going this way. That the x component, the component that's going in on this one, and the component that's going in on this one cancel each other out. So their side-to-side motion kind of cancel each other out. What's left is that they're both pushing up this way. And that ends up being your overall polarity. If you need to get like something that's got wheels on it and get two people to push on it, or attach some ropes and just kind of see what happens when you pull on different ropes and so on, is a good way to visualize this. But once again, if you have kind of a physics diagram and you're more familiar with adding and subtracting forces, this will work pretty easily for you. Okay, so that's polarity. You use the electronegativity values to draw the arrows on the bonds, and then we use the structure, the shape, to figure out what the polarity is for the molecule overall. Okay, so this part's really easy. Okay, so you should be able to get that pretty quickly. Just look at the values. You'll always be given to you. Or you can look at the table in your workbook, and then you figure out the polarity based on that, of whether or not they cancel each other out. The canceling each other out part becomes better as you become more familiar with it. All right, so that's polarity, and like I said, we'll add the Vesper lesson next that will kind of help you understand the shapes a little bit better.